Hello everyone. Welcome to the lecture class of Structural Design and Drawing. In this class, we will see the introduction of Unit 4, that is Industrial Structure. So in the introduction part, we will be discussing about the main topic, that is the roof truss, and what are the different types of roof truss available and how it is analyzed. Okay, so we'll see in detail about all these topics. Okay, so you can see in the picture there's a steel structure. Okay, it is nothing but your truss. It is a triangulated system. Okay, triangle system of straight line which is interconnected to make a structural element. Okay, the most common use of these trusses is to support the roof, floor, and internal loading, such as it can be a suspended ceiling or already which is provided. Okay, we'll see in detail. So design of steel truss. So it is a framed structure in which the separate straight elements are arranged and connected at the ends to form a triangulated system. Okay, so normally the span of the truss is 6 meters. So where it is used in industrial shed and ceiling for large room, auditorium, cinema halls, and marriage halls. Okay, so the main highlight of the members in trusses are it carries the compressive force. Okay, so the compressive force, the member which carries compressive force, we call it as strut. The member which carries tensile force, we call it as tie member. I'll show you in picture what is tie member and what is the strut. Okay, so in the first picture, you can see an auditorium. Okay, so on the top most we have a triangulated element. Okay, so in a closer view, this is how it is. In second picture, you can see it's a triangulated member which is made up of straight element. Okay, all these straight elements are arranged and connected at points. Okay, so all these structural elements combined form a truss member. Okay, so we have two different members. We have strut, and another one we have tie member. Okay, the bottommost member, okay, the bottommost horizontal member we call it as tie member, which carries the tensile force, whereas the inclined member, okay, this portion we call it a strut. These carries the compressive force. The compressive force member we call it as strut. Okay, so usually the load is applied at the tip of the truss, and the load is eventually distributed to the adjacent members, and it reaches the load reaches at the support. Okay, and you can see the auditorium in music concert. We have 4-leg trusses are also available. So the main components of roof truss, we have main member and secondary member. Okay, so main member means it carries the load and it helps in distributing the load. The secondary member, it helps in the stability. It provides stability to the main member. Okay, we have the picture. We have top chord member. Okay, this inclined member we call it as top chord, and the bottommost the tie member we call it as bottom chord member, and the in between the members we call it as web members. And what created a need for roof truss is first one is daylight requirement. If you need more headroom, roof truss is provided, and the clear span is also more in the case of if you provide a roof truss, and it doesn't require any internal support, and it reduces moisture content and provide ventilation and other advantages. Slow on. And disadvantage and advantages of roof truss is it can be suitable for sloping roof, and if it is suitable also for high light load and larger span. Okay, and provides there is a variety of roof shapes are available. And if you want to achieve a greater headroom space, which is vertical span, you can go for adapting a roof truss. And the most economical span is, as I said in the first slide, it is 6 meters. Okay. And when you come up on the disadvantage part of roof truss, one is the problem in transportation. Okay. And the aesthetic appearance is very low when compared to the other concrete structure. Okay. If the roof truss is made up of wood, it is very much susceptible to fire, and the cost is higher when compared to the other construction. And since we are using steel in the roof truss, it more susceptible to corrosion too. Okay. And we have second next, we have the various terms that are used in steel roof truss. We have span, rise, pitch, slope, purlin, rafter, slitting, panel, bay, ridgeline, principal rafter, chamber, and caves. Okay. This shows you about the king post roof truss. Okay. The topmost point we call it as ridge. Okay. This is the inclined portion, is nothing but your principal rafter. Over that we have common rafter. So okay, in between common rafter and principal rafter, we have the purlin lines. Okay. So these members, we call it as your strut member, that bottommost is your tie member, and the whole roof truss will rest on your support. That is nothing but your wall, the supporting wall. Okay. In types of steel roof, we have based on material, we have timber truss, steel truss. Okay. Steel truss is more economical when you have a larger span. Okay. If the span is more than 10 meter, timber truss is found to become very heavy, and that also results in uneconomical section. Okay. So most of the steel trusses, we use angle section because they can have the ability to withstand both tension and compression. Okay. So broadly, we have open truss, light truss, north light truss, and bowstring trusses. Okay. Based on material, we have steel and timber. Based on categories, we have based on the shape, we have open truss, north light truss, and bowstring truss. So these are the examples of truss here. We have some example for north light truss. In the last portion, we have bowstring. Okay, in the bow and the string, it's like bow and the string. Okay. So these are the examples that have been given for north light king post trusses. So when coming to the analysis part of truss, the truss members are considered as pin jointed. Okay, so that it's pin jointed, it transfers only axial force, not the moment and shear force is not transmitted from one member to the other member. Okay, and we also assume that the load is only acting at the node. Okay, the node is the point where two straight members connect. I'll come back to the previous slide. I'll show you what is the node. So this point, okay, this point is called as node. This is called as node. Where the two members join, we call it as nodal point. Okay, so we consider the load only acts at the nodal point of the truss. Okay, and truss may be provided as single span. Okay, and it's simply supported over two end support, so that, which is in the case of usually statically determinate structure. So you can analyze the truss by method of joints and method of section. So we also use computer program for analyzing truss members. So as I said, we assume it is as pin jointed, and we also assume that axial forces are on the different members are also found. Okay. The members are connected either by bolts or welding. Okay. And some particular cord members may be continuous over the other nodal also. Okay, to have that, we have compatibility of translation and compatibility of rotation is also considered enforced. So in this video, we have discussed about what is roof truss, why we went for the usage of roof truss, and what are the advantages and disadvantages and different types of trusses available, and what are the assumption that is made in the analyzing of the truss. Okay, is that clear? And thank you.